Our objective for today, I can solve and graph linear functions. Let's read together. 1, 2, 3. I can solve and graph linear functions. So we're going to continue with functions today, but today specifically we're going to look at linear functions. What are they? So I gave you guys the Cornell note for this. So if you don't have a Cornell note and you're making your own, make sure you sketch a Freire model. Linear functions. Definition. A relation that assigns exactly one output value for each input value. It has two variables, and it has a constant rate of change called the slope. That sounds familiar, right, from last year?
Yeah.
Okay, examples. Now, look at the first part of the definition. A relation. A relation is a collection of ordered pairs. Is that correct?
Yeah.
Do we have a collection of ordered pairs here?
Yeah.
Yes, that's why it is a linear function. But it's a linear function specifically because for each input value, there's an output value. So for each input, there's exactly one output value. However, what you don't have written is this. Write this down, please. Y equals 2x plus 1, y equals negative 3x plus 4, and y equals 2/3 x minus 23. Also, on the non-example side, I give you guys a relation, which is that. I also give you guys a graph that looks like this. And I also, one thing that you don't have is this, y equals x squared plus 4, and y equals x cubed plus 1. Those are the things you don't have on your notes. So I'm going to elaborate on the definition to make sure that we understand where we're at. Here it goes. So, according to the definition, what's that? Yeah, left light, please. So, according to the definition, a linear function is a relation. Do you agree so far? Is this a relation? Yes.
Yeah.
But what's so specific about this one? Because isn't this one also a relation? Yes. But what's so different about a linear function? That for each input, there's exactly one output. What does that mean? That if I was to pick any x value from here, and I would say I'm going to pick negative 2, how many values come out when I use negative 2? What is this value? 3? Isn't this the same value?
Yeah.
So it's only 1. Or in other words, if the x value repeats, it has to have the same y value. Does it have the exact same y value? Yes. Okay. Now let's look at the non-example. This is also a relation, but look at it. Don't say it out loud. Why is this not a linear function? Don't say it out loud. Why is this not a linear function? Talk it over with your neighbor. Why is that not a linear function? So, let's see. If I was to select negative 2 over here, what is the output value for negative 2?
3.
3. What else? 7. So that means this one has how many? 2 different outputs. And what does the definition say? Exactly one output for each input. Over here, if the negative 2 repeated, guess what? The y value is the same here, so it's only one output. The x value repeated over here, did it have the same y value output? No, it had 2 different ones. That's why this is not a function. Are we there so far?
Yes.
So now, what other information do we have here in the definition? 2 variables. So if I was to write this as an equation, here they are. So do we have 2 variables? Yes. 2 variables, 2 variables. Do these represent 2 variables? Yes. X and Y, X and Y, X and Y, X and Y. Okay? And it has a constant rate of change called the slope. Now, I'm going to introduce slope not too long from now, like one more lesson up, but I'm going to give you a quick glimpse right now. This is the slope. This is the slope. This is the slope. That is only true if this has that, this has that, and this has that. With that, what I just showed you, what is different from these to this? What is different from these to these? Talk it over with your neighbor. What is so different from the non-examples to the examples? That is true. These have an exponent of what? 2 and of 3, and these only have exponents of 1. So linear functions cannot have exponents greater than 1. Are we there? That's why these do not have a slope, a constant rate of change. So therefore, what is our critical attribute for linear functions? That they are relations. Do you agree with that?
Yes.
That they have one output for each input? Yes. And that they have a what? A constant rate of change called slope. Copy that, please. So as you're finishing up that, check this out. I'm going to show you what the graph representation of the equations look like. Here we go. Let me go back to the previous one. Oh, right here. So watch. Look up, please. I said that for this one, this was the slope, right? For this one, this was the slope. And for this one, this was the slope. So now let me show you what the line looks like for those. For this one, it looks like this. For this one, it looks like this. And for this one, it looks similar to this, but instead of going up like this straight up, it starts going slower like this. Everybody see? This one's going straight up. This one's going straight down. This one's going up, but very slowly. It will eventually get to that point way over there. Hold on. So now, do you notice the resemblance here as to why this one is like that and this one is like this? Think about it. Why is this one like that and why is this one like this? Talk it over with your neighbor, please. Who saw that this was a positive, and going like that, and this was a what? And it's going like that. Are we there? So now let me show you what these look like. Why these are not linear functions. Let me show you the graph for those. Pay attention, please. Here he goes. Let me show you what the graph looks like for this one. Look up, please. That's this one. Let me show you this one. This one looks like this. What do you notice? That these are what? Straight lines, and these are called what? Curves. These are straight lines, and these are curves. So now check this out. And the answer, check this out, guys, what we just said lies within the term. Watch. A straight line. Copy that, please, so you remember that linear functions are what? Straight lines. Okay? So, now let me elaborate a little bit more. Now check this out. So now that we understand that linear functions are straight lines, look up, please. Let me show you a linear function. Look up. Is that a linear function? Yes, because it's a straight line. What if I turn it like this? Is that a linear function? How about there?
Yeah.
How about there?
Yeah.
How about there?
Yeah.
How about there?
Yeah.
The only time it's not is when it's like this. Well, hold on. Let me... There, like that. So think about it. If all others are functions and not that one, let's say yes, function, yes, 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 no. So what can we conclude? Talk it over with your neighbor. Hold on. Once again, so that you remember, a vertical line is not a function, and I'll show you why in a little bit, okay? So let's move on. We have steps, don't we? I already gave you the steps. It says write a rule for the function, graph the function, solve for y. You already have them on the Cornell notes, and use an input-output table. Test your graph to see if it's a function, and evaluate the function after writing in notation form. So with that said, turn your paper over. In the back, there's going to be a graph, but before we get there, so watch. In tonight's home play, you're going to have some problems that are like this. Word problems. Look up, please. They're going to say something like this. Many stretches on the German Autobahn have a speed limit of 120 kilometers per hour. If a car travels continuously at this speed, y equals 120x gives the number of kilometers y that the car would travel in x hours. This is a function. Now, how do we know? Here's the representation. Let me see. For the x value of 1, what is the output? 100, or 120. For the x value of 2, what is the output? 240. There it is. For the x value of 3, 360, and so on and so forth. Is there one input for every one output? Yes. That's why this is a linear equation, but also known as a linear function. Are we there so far? All right, so with that said, at the top left of your paper with that graph, I want you to write this problem down, example 1a. Write the words for this one. It says graph y equals 2x plus 1. Tell whether it represents a function. Copy that, please. Okay, so according to the steps I gave you, step 1 says that you need to come up with a rule, but they already gave us the rule here, right? But step 2 says to graph. And how do we graph? What does the parentheses say, Amanda? Step 2 in the parentheses, what does it say? Solve for y. And use an input-output table. So check this out. Look up, please. Let me get this out of the way so we can see it a little bit clearer. Look at this equation. Y equals 2x plus 1. Is it already solved for y? Yes. Y by itself, that's why it's solved for y. Are we there so far? So at that point, all we need is to build an input-output table. So watch. Let me bring this over here. And we're going to build an input-output table right there next to our graph paper, y equals, or our coordinate plane. You're going to write that down like that. And for domain, from this point forward, for those of you that stayed with me yesterday, we said from -3 to 3, but today we're going to use from -2, -1, 0, 1, 2. And for those of you that forgot what the domain was, domain is all values for x. All values for x. So what values are we using for x? -2, -1, 0, 1, and 2. That's my domain. Are we there? No, right now we're going to keep it up to right there, but when we graph it with the arrows, it indicates that it keeps going. Okay, so here we go. I'm going to zoom in so that we can see some of the work. So check this out. So basically, I'm going to write this equation right here next to it. And I'm going to write y equals 2, and instead of x, I'm going to open up parentheses, plus 1. So what is my first value that I need to substitute in there? -2. That goes in here. What is 2 times -2? Y equals -4 plus 1, because I bring this down, right? What is -4 plus 1? -3. That goes right here. And let's plot that point. Here we go. On your graph. -2 of x is right here, circle that. -3 of y is down here, circle that. And they both meet up, we're at right here. Remember that from last year? Yeah, right? Let's go with our next one. What would be our next value? Negative 1. So I'm going to substitute that in here. Let me erase that. If you want to do the work next to it, that's fine. If not, just follow along for right now. 2 times negative 1 is what? Negative 2. So what is negative 2 plus 1? Negative 1. So that goes here, and let's plot that point. Negative 1, and that is right there. Are we there so far? Okay, fill in the table, please, by yourself. Go. Okay, let's see. The next value. We substitute 0 in there, right? Yes. So if we substitute 0 in there, what do we get for the y, Haley? One. Hands, have you got that? That is correct. Yeah, if you substitute 0 in here, what is 2 times 0? 0 plus 1, 1. So let's graph that. X is 0. Where's x 0? Right here. Where's y 1? Up here. So where do they meet up? Right there. So far so good? What is my next value right here? Okay, go ahead, Stephanie. 3. Hands if you got 3. That is correct. 1, 3, and it's right there. And what's my last value, Wyatt? 5. Hands if you got 5. That is correct. So this is 2, 5, and it's about right there. Get your ruler. Draw your line, make sure it's nice and straight. Let me zoom out for this one so I can see it from far away. Let's see. I'm going to use red for this one. Nice and straight like mine, going through all the points. You guys see that? Pretty good, huh? All right, so first part is right. We graphed this. What did we, to make sure we go over the steps, is it solved for y? Yes. Did we use an input-output table? Yes. Did we graph our line? Yes. So now let's check to see if it's a function. Look up, please. First of all, do any of the x values repeat? No. No. So from right there, we already know that this is, yes, a function. But just to double check, I'm going to show you another way of checking. This is called the vertical line test. What is it called? Vertical line test. So this is what it does. I use a vertical line. Here it goes. Is that line vertical? Yes, it's straight up and down. It's a vertical line. And I'm going to scan, using that line, that vertical line, the line that I just graphed from left to right, to see if it touches at one point all the way. Everybody with me? Yes. And if it does touch at one point all the way, it is a function. However, if it touches at more than one point, it's not. Now, how do we do this? You can do that with me from far away. Use your ruler. Use the spine of the ruler, this part. Kind of aim it like that and overlap my line that I have up there. And just follow along with me. Here we go. I'm going to move it with me so that we can go over that red line. And here we're on the line already. Do you guys see it? Yeah. Okay, but it's only touching one point all the way through. Is it touching one point, one point, one point, one point? Yep, that is a function.
Wait, what?
Now, for some of you, it's still not clear. Here, let me illustrate in a different way. Pay attention. Watch. A line, basically all it is, look up please. A line, all it is a lot of points together. That's a line. Does everybody understand what I'm saying? Yes. A line is a lot of points put together. Watch, because if I was to zoom out here, oh, sorry. Does that look like a line? Does that look like a line? Yes. And if I was to test, watch. If I was to test it with my vertical line test, look, and we move it through here, is it touching at one point? You're like, it looks like it. Well, let me zoom in so you guys can see it. Is it touching at one point all the way? 1 point, 1 point, 1 point, 1 point, 1 point. That's why it is a line. Because I just said that a line is a bunch of points. Okay? Yes? Not a function.
Oh, vertical line?
Yeah.
That can't be one because like the straight line that touches it.
Bam! Did everybody hear that?
No.
So watch. So they said, look up please. Haley said, is that why, look up please, this is not a function? That is why, because if I take my vertical line test, watch, get your ruler, scan that line from left to right, does it touch at one point? No, it touches at all the points. Look at that. It touches at all the points. That's why it's not a function. Does that make sense? Okay? So, with that said, let me go back to the previous one. So, does everybody understand what a function looks like? Yes?
Yeah.
So now let me show you another way of saying what is not a function. Here we go. So look up, please. Watch. Look up, please. Here he goes. Remember I showed you this graph? This is a cubic. Remember that? Something like that? And if I was to ask you to use your ruler and go and scan it from left to right, and let me show you with my vertical line test. Here he goes. Here he goes. I'm going to scan it from left to right. You can follow me with your ruler. Is that a function? Yes, yes, yes. Yes, it is so far. Yes, 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 yes. So far up to right there, yes, right? If I was to stop there. But, yes it is? No. Now let's find out why it's not. Let me zoom in. Check this out. Hold on. Let me zoom in. How many points is it touching that graph? 4. 4? Here it goes. Look up, please. Here's 1, 2, 3. 3 points. Is that correct? All right, that's why that is not a function. All right, let's continue. So with that said, on the right-hand side, the graph to the right-hand side, copy this one. Example 1B. You don't have to copy the instructions anymore. You already have them. So just write 1B and copy the equation. It says graph 15x plus 3y equals 9. So, step 1 was a rule. They gave us a rule. Step 2, is it solved for y? No. That means we need to do that first. Y needs to be by itself. This needs to be by itself. What's next to it? 15x. It's a positive 15x. How do we cancel that? Minus 15x minus 15x. We're left with 3y equals negative 15x plus 9. What do we do at the end? Divide by 3, divide by 3. Y equals negative 15x divided by 3, that's negative 5x. 9 divided by 3 is positive 3. Are we there so far? Now that we have it in y form, what's the next step before we graph it? Input output table. So you do x, y, Tell your neighbor the domain we're going to use. Negative 2, negative 1, 0, 1, 2. So fill it in, please. Do that by yourself. I'll just help you with the first one. Here we go. Negative 2. We substitute that in here. That becomes y equals negative 5 times negative 2 plus 3. Y equals negative 5 times negative 2, that's positive 10 plus 3. And what is that? 13. And I'm going to graph that. Negative 2. And this is 8, 9, 10, 11, 12, 13. And it's about right there. Fill in the rest, please. Go. So, the next value is negative 1. What is our y value for that one, Sage? If we substitute negative 1 here, what is negative 5 times negative 1? Positive 5. So this is 8. So let's graph this. Negative 1 and 8 is about right there. Hands if you got that so far. Okay? Next one. This is an 8. For the value of 0, Amanda, what do you get for your y? 3. 0 is here. 3 is up here, and they meet up right there. Okay? Now, check this out. Some of us actually see a pattern forming. Look up, please. From here to here, something happens. From here to here, something happens. Richard. Subtract 5. 13 minus 5 is 8. 8 minus 5 is 3. So therefore, 3 minus 5 is what? Negative 2. And then from there, it's negative 7. Hands if you got that. Okay? So let's plot those. This is 1, negative 2. 1, negative 2. It's right there. And 2, negative 7 is down here. Get your ruler. I'm going to do that in blue. Graph my line. There it is. So, they're asking, is that a function? What would you say? Yes. A function. You write that in there. Function. And how can we tell if it's a function? What can we do? Yes, vertical line test. Or, which other way, Elizabeth? What can we do? What can we tell from here? Did the x repeat? No, so therefore we can assume that it is a function. If it repeats, it has to be the same y output, right?
By assume, you mean most likely it is?
Most likely it is, yes.
Oh.
Okay? Example 1C. Copy this one down on the bottom left, the graph to the bottom left. You don't have to copy the instructions. This one is, and once again, they're asking to see if it represents a function. But they give us x equals negative 2. X equals negative 2. You're saying, that looks weird, Mr. Q. It does. So now check this out. What do you guys notice is missing? Evelyn, the y. You guys notice that there is no y. Okay? So check this out. Look up, please. Let me zoom in. If this was, what was the equation? X equals negative 2. If I was just to have a number line here, and I said graph x equals negative 2, where would you put your point? At negative 2, right there, right? And we would be done. But since now we are in two variable equations, now we cannot help by seeing that we have a y-axis. Do you guys see the y-axis here? Yeah. That means that there has to be a line going through this point. Let me show you that line. Okay, kinda. Is that line going through that point?
Yes.
Yes. What do you guys notice also of that line? What is that line called? Don't say it out loud. Talk it over to there. What is that line called? Haley. It's a vertical line. And if it's a vertical line, what? It is not a function. So graph that like that, please, and write not a function.
On the third box?
Yes, on the bottom left box, yes. So now, this is for x equals -2. X equals -2. It's not a function because it's a vertical line. Now check this out. How else can we tell that it's not a vertical line? Watch. Look up, please. X, Y. If I was to do a table, let's see. At -2 of x, let's see. What would be Y? What is it? 1. At -2 of x again, what would be Y? 2. And then 3. And then 4. And all the way down to the negatives also, right? So let me ask you, how many outputs do we have for -2? A bunch of them. Therefore, that is not a function. You guys see that? Okay. Any questions with this? Yes.
You know how you said, kind of like the vending machine, if it repeats the number, it has to be the same one?
Right.
So then it would be -2, 1, -2, 1.
It should have been -2, 1, -2, 1. But since it's not, that's why we can tell that it's not a function.
So if it just has one dot, but like it doesn't...
What do you mean?
Because like...
Didn't I just say that a line is made up of a bunch of points?
Yeah.
So what points would you put here? This one, 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 right?
Yeah.
And the arrows say that it continues going, right? So what is the value of x? 2 for all those points. So therefore it's a lot of outputs just for 2. Okay? So on the bottom right, copy this one. Example 1D, y equals 8. Y equals 8. So think about it. Look up, please. If x equals -2, I plotted -2 and the line went through that. This is y equals 8. Y equals 8 is right there. What would that look like? Here it goes. Does that make sense? Yeah. And this one, is this a function? Yes, this is a function. Yes, function. Function. And we can do the vertical line test, right? And see that it touches only at one point.
So it's just like, if the x is like alone, like it's not a function.
Exactly. Exactly.
Oh.
Okay, everybody got it?
Yeah.
All right. So, turn your notes around to underneath the steps that I gave you and copy this diagram, please. It says forms of linear equations.
On the line, right?
Right here?
I said copy that diagram.
But, never mind.
Okay, so that you know where we're going, here we go. Forms of linear equations. We have this form that we've looked at, y form. It looks like this, y equals -5 plus 3x. But we can also write it as y equals 3x minus 5. This has a particular name. This is called the slope intercept form. And we're going to be using this most often. The other form that we need to look at is this one. AX plus BY equals C. This is called standard form. The last form that we're going to look at is Y minus Y1 equals M times X minus X1. Okay? Now we've seen this already. Look at the example that I gave you earlier. Watch. Look at this one. Stop, please. Look at this one. 15x plus 3y equals 9. Doesn't that look like this? 15x plus 3y equals 9? Yeah, it looks like that. So check this out. We're going to be working with that. So look at this one. Copy this one. Last example. Example 2a. You can copy it on the Q side. On the Q side is fine. Write x equals 2y plus 4 in standard form and give the values a, b, and c. Now where you write standard form, I want you to write ax plus by equals c. So, look what they give us. X equals 2y plus 4. Does this look like this form?
Yes.
Not really.
No.
What do you notice here from this?
Doesn't have a variable. Well, second one.
Okay.
Two variables.
Who notices that the x and the y are together on one side of the equation? Look up. Here's the equal sign. Who notices the x and the y are on the same side? So what do we need to do here in order to get both variables on the same side? What is it? Subtract 2y. That is correct. Subtract 2y. Then we get x minus 2y equals 4. Does that look now like this? Yes, right? So check this out. So they're asking us to identify A, B, and C. What would be A? No. What is the coefficient? 1. What is B? -2. And what is C? 4. Everybody see what we did right there? So for home play for tonight, I need you guys to go to pages 160 and 161. Wait. But those of you that did not make notes for the lesson prior, you need to make those notes. Yes. The same video that we just did. Thank you. Have a good one. Enjoy your homework. See you guys. Home play. See you guys tomorrow.